Now let's get this started with our world-renowned opening headliner who will be talking about the intersection of generative AI as well as climate issues. So Professor Simon See is currently the Solution Architecture and Engineering Director, Chief Solution Architect and Global Head for NVIDIA AI. He's at NVIDIA Corporation. He is also an adjunct professor at the Shanghai Jiao Tong University, Coventry Universities, and the Universitas of Indonesia.
Professor See's interests are in the area of high-performance computing, big data, AI, machine learning, and computational science.
So everyone, please welcome Dr. Simon See to the stage.
Thank you very much, everyone, for having me here in this conference. First of all, I want to do a short disclaimer. I'm not an expert in AI. I'm an applied mathematician who happen to use AI. Now, as you guys know, climate change is here to stay. We all have experienced it in one way or another. I have the privilege of traveling around the world, collaborating with different universities, different research institutions, and also with government agencies. And during the travel, I actually have experienced some of these tremendous extreme weather. And recently, I was just in Hong Kong. I was caught in the tremendous rain. This has been studied by many climate scientists. They have done simulations many, many times, studying how the Earth is going to change, predicting what will it look like if we are 1.5 degrees over what would the limit right now, and so forth. And the conclusion is that we're going to see more of these extreme weathers. There'll be see more drier land, see more wetter places, more rains, and so forth. And we are going to experience that in one way or another. So the question is that with this, how are we going to mitigate all these problems? As the earlier speaker have said, AI is now here. And the question right now is that how can we actually enhance this technology to be able to use it to actually help us in doing some of these climate change issues. So perhaps let's take a look at, just to give a short little idea of what is do when we do modeling of the planet Earth. Before we start to save the Earth itself, we need to understand how the climate scientists model the Earth. And these are some of the way that the components that have been used. Their data simulation, you have satellites all over the tip collecting data. And you do dynamics about the planet Earth. The physics itself is complex, and of course, the integration of all these things together. The challenges is that this is a very chaotic. Weather is simply chaotic, right? The data that we're collecting is incomplete. And the short time solution. We want to know when the next flood is coming. We want to know when the next flash when the rain is coming, and so forth. So this is time to solution is extremely important. And needless to say, finite resources. I'm going to talk about it a bit more later. To do all these things, and I just, don't worry about this too much. Just to flesh it out, these are just some of these simple equations that we use to describe a climate. And usually, the climate scientists and the computer scientists will do complex equations to actually put them into a discrete form and able to put them into our computers. The problem is this. The problem is that right now, we are able, with the largest machine on this planet, we are able to do resolution of 1 square kilometers. Basically, it means that if we discretize the Earth, the planet Earth, the resolution they can see is one planet, 1 degrees or 1 square kilometers. Even with all the changes that we have made and the advancement that we have made in semiconductors over the years, NVIDIA's, my company has been working on GPUs, and we have actually improved the performance over 1,000 times over the last 10 years. It is still not enough. Basically because if we want to do a 1 meter resolution, we need a computer that's about 100 billion times more powerful than what we have right now. Instead of trying to save planet Earth, we are destroying the Earth if we were to build that machine. Just to give you an idea, and this is where I come from. I come from a place called Singapore, a small little island, still smaller than Holland. Although you think that Holland is small, Singapore is even smaller. This is how big Singapore is. Sometimes, if you Google the little red dot, Singapore will come out. It's called the little red dot by its nickname. And this is how big is one degrees resolutions. This is how big it is. Basically, it means that Singapore is 4 outside the 1 single cell. Technically, it is very difficult to simulate that. And Singapore is a very hot island because Singapore is urbanized. We have almost 60% of the island is tall, high-rise building, factories, roads, and whatsoever. And the amount of heat we generate is humongous. And the island itself generates out a lot of heat. So could we actually use artificial intelligence to do climate modeling and so forth? We take a look at it. I mean, the state of the art right now is that we see that over the last 10 years or more, that AI has progressed tremendously. You have AI that is do better than human being, and the technology is mature enough to be applied to many things. MRI scans, image, facial recognitions, image processing for medical health, and so forth. You can even use for emotion analysis, and this is a real-time AI emotion analysis project. Now, are there ways to combine AI and Earth system models? And we think there are ways of doing that. In fact, there are a lot of works going on right now, and these are some of the subset of works that's going on right now in the world that using artificial intelligence to do some form of weather predictions or climate analysis and so forth. Like I said before, there are data missing, so we can actually use machine learning or whatsoever to actually fill up those missing data and stuff like this. One of the works that my team is working on together with University of Delhi is to use AI to model clouds. Clouds is a very complex problem. So we use it to actually model clouds itself. There is a technology called the physics-informed neural network. And basically the whole idea is to combine neural network together with the physics that we have learned for hundreds of years. And this is called physics-informed neural network. And this is the works that we have been working around the world with many things. One of them is with Siemens. And I'm going to show you videos of it and what we are doing together with them.
Total worldwide wind energy capacity currently exceeds 750 gigawatts and is growing faster than ever, with an additional 650 gigawatts to be added in the next 5 years. For companies like Siemens Gamesa Renewable Energy, optimizing the configuration of each new wind farm is critical for getting the most out of their investment and reducing costs for consumers. When designing a wind farm, it's critical to place each turbine so as to minimize the effects that turbines have on each other due to the wake that they create. Accurately modeling the wake requires high-resolution, high-fidelity simulation data that is specific to that wind farm such as the geographic location and the terrain. The gold standard for generating this data is the large eddy simulation shown here. But to run just one iteration for a single turbine can take 40 days on a 100-core CPU. And with so many iterations needed to develop an accurate model for a specific site, using CPUs is impractical. Using NVIDIA Modulus and NVIDIA Omniverse, Siemens Gamesa has been able to reduce that 40 days to just 15 minutes.
40 days to 15 minutes. In terms, it saves a lot of computational time, it saves a lot of energy. The other things that what capture a lot of attention here is generative AI. And what is generative AI is about? It is about putting in all these data, putting them into some form of statistical models, and then able to generate out different images and text and all forms of data. Of course, many of you are already very familiar with Midjourneys and stuff like this that has been created, and other things that we have actually been done. Things will be like the videos, setting up prompts and able to generate out videos and so forth. There are other technologies that has been created, and many of you will have already used this, DragGAN, and then the Adobe's technology, which allowed you once to actually do all sorts of things in the double very quick time. But one of the very interesting things, and some of you, if you are as old as me, would know that in 2002, there was a movie called Minority Reports. And the whole idea is that the movie, of course, is a science fiction. It's about reading the mind of a pre-court and able to generate out what is the crime that's going to happen before. That's a science fiction. Now, over the last few years, people have been toying around the idea, not so much as to predict what the crime is going to be, but able to actually read the mind of it using generative AI. And these are one of the examples of my friends in Osaka University that actually, in fact, able to use the MRI scan, reading the MRI scan, and then able to generate out the images. The top rows is the images that's shown to the patient. The bottom rows is the one that's generated out by the generative AI. There are other experiments using mice and so forth. And one of the things is that recently, University of Hong Kong is able to use some things that using the videos. So the same thing, feeding the videos, and then reading out the thing. What is it useful for is that it can be used for science. It can be used to study people like schizophrenia. What do you think how a schizophrenia patient would think? How do we then apply this into generative AI for weather? We can use it to predict a weather, such as examples. One of them was called ForecastNet, developed by my colleagues in NVIDIA. Pogu Weathers developed weather in China, and now CastNet develops over in things. It basically uses technology like transformers and all sorts of generative AI technology. Recently, we have also works on reducing the resolutions, things that are able to improve the resolutions of the, forecasting much better by using such generative AI. And what you have produced is that you have allowed us to accurately predict rains in 3 days, right? 60 times faster than the current model. And one of the very important thing is almost 100 times much better. Now, ChatGPT has been around for a long time. I mean, not for a long time, for 6 months. It sounds like a long time. And everybody has been talking about it. And you have people like creating ChatGPT, and many of you will have used ChatGPT in one way or another. But what's interesting to me is the ability for using ChatGPT as an autonomous agent. Agents that's able to actually help us to make decisions, help us to make the differential tasks. And the other are examples of it. One of them is actual facts produced by Hugging Face, is Hugging Face GPT. And another example is the Chat Crunch, which basically is an AI tools to help engineers and scientists to develop simulation in a much, much faster way. Now, generative AI can be used in many things: drugs design, material design, design better solar panels, design better batteries, and so forth. The whole idea about generative AI is that you can use it to do this. Instead of you, as engineers or scientists, to design only one component or two components because the limitation of your imagination, what you do is that you let the machine automatically generate out 1,000 different scenarios you need to only provide the specifications of what the technology is. So with that, we hope that we are able to actually move from the current things to able to move on to produce a computation machines that are able to do modeling about 1 billion times from now. We're still very far away. In NVIDIA, we are trying to put all these things together, from visualizations to computational and stuff like this. So one of the things that the whole idea is that what we want to do is to be able to simulate thousands and thousands of models, right, in a very, very quick way with the current limited resource. So not just by improving the semiconductor technology, we need to relook at the way that we do the math. We need to relook at the way that we do modeling. And how do we actually use AI to solve all these problems? So with that, I thank you very much.
Microphone on. Okay, fantastic. So we have now 5 minutes for a very quick Q&A. We have volunteers roaming around with microphones. So who would like to raise the first question? Please raise your hand. Please introduce yourself with your name and, if applicable, with the organization you work for. Okay. First question. Don't be shy. Yes, the lady over there. Microphone is coming to you.
From Adaptive AI. This is an awesome presentation. Thank you. I like the way you pieced the traditional machine learning and capabilities of AI to what can be done with generative AI. Could you clarify one bit of information? In the way you moved from traditional AI to generative AI, you spoke about the difficulty in creating a resolution that's above and beyond that 1 square meter. Do you mean that with generative AI, we could potentially solve that problem?
Yes. With generative AI, technically, it is possible. However, at the moment right now, we still lack the amount of data. So data is now one of the major culprits in this thing. We are slowly moving towards that. We are trying to look at new algorithms and new mathematics in solving that problem. Does that answer your question?
Next up, yeah, the gentleman just over there who's raising his hand. Microphone is coming.
Yes, I second that. Excellent talk. Excellent. So I hear a lot of talk in the community about the possibilities that we've hit a plateau in generative AI, that the current model will not be able to go much further than it does now with ChatGPT and others. What are your thoughts on that? Do you think that we're at a plateau, or you think it's going to go forward? And if you think it's a plateau, what do you think the next steps are?
A good question. Well, there is a couple of things that there's a couple of problems that we are facing. One of them is, potentially is the actual fact, what we call model collapse. And basically, the model collapse is that we are doing a lot of synthetic data, using generative AI to generate those data, and then we reuse those data, and then we reuse those models again. And then what we have is that we are not able to capture what is going on at the tail ends of the statistical distribution. That is one of the limitations if we move forward with that. Generative AI, at the moment right now, is one of the challenges that we have is that we have yet to really understand the algorithm extremely well. We do know that it works. We do know that it's able to generate certain things, but we still do not understand it. From a mathematicians, we still do not understand where are the upper limits and what are the lower limits is. And so there is still a lot of research need to be done to do things like uncertainty quantification and so forth to help to understand where the models is going. And then from there, we can then further improve on that model.
I saw there were some further hands raised here across the room. I'm afraid we're already out of time. However, our speakers will be here, so you can just grab them and ask them some further questions if applicable. So ladies and gentlemen, please thank our speaker, Dr. Simon See.
Thank you.